Hey guys, okay, so this week we're going to be doing input-output tables. We have done this before in class, so this week is a review week. So if you need some reminders, that's why we've got some fun anchor charts in here for you. So this is one that will help you throughout these problems, okay? And if you need to go and reference this poster back while you're doing your work, then you can, okay? So sometimes we see input-output tables as vertical tables like these, okay? The information is going down, okay, and written down, and then sometimes they're written horizontally, so sometimes they're going across, okay? And that means we're looking at numbers like this is our input and this is our output. So one kid is going to drink 2 cans of soda. Well, when we're looking here, we have set A and set B have a relationship. So we have 4 and 10 have a relationship. 6 and 14 have a relationship, okay? So what I like to tell my kids in my class is that, when we're doing input-output tables, we have to try and find that relationship. Numbers have relationships, just like addition and subtraction have a relationship because they're opposite of each other. And I can check addition problems with subtraction, and I can check subtraction problems with addition. So it works the same way with multiplication and division. Those two numbers, those two operations work hand in hand together, okay? So like I said, I just wanted to put this here for you for a reference. Okay, this problem says Casey sold bracelets at a store. She sold 3 bracelets for $1. Which table represents the numbers of bracelets that would be sold for different numbers of dollars? So in this problem, we have a relationship between money, the number of dollars that she makes, and the bracelets. Okay, that's our relationship here. Okay. So, and as we see in each one of these problems, we have number of dollars and the number of bracelets. So that's why I put dollars on this side and bracelets on this side. Okay. Fun fact, Miss Sims' first name is Casey. So I really like thinking that this problem is about her. But she spells hers with a Y in there. So this isn't how you spell hers, but her first name is Casey. So that's why, like I said, I always think about her when I look at this problem. So anyways, okay, back to our information. So we sold 3 bracelets for $1. So I'm going to put $1 right here because I know this is $1. Okay. And I sold 3 bracelets for $1. Well, how many bracelets would I make if I paid $2? How many bracelets would I then have? Well, 1 and 3. Remember, this is bracelets and money. So what I would need to do is find the relationship between these. Well, if I paid $2, would I get 4 bracelets? Well, that doesn't really make sense since when I'm paying $1, I get 3 bracelets. So here for $2, I'm going to get 6 bracelets. Okay. And again here, $3. How many bracelets would I get? Well, for every $1, I get 3 bracelets. So 3, 6, and 9, because I also know that 3 times 3 is 9. 2 times 3 was 6. 1 times 3 was 3. Okay, so this is our input, our dollar amount, and our rule is times 3. Okay, that's the relationship. It's going to be times 3. And our output, what our answer is how many bracelets I get each time that I sell the money. Okay, or sell bracelets and I get money. So 3, 6, 9. So how much would I get if I got $4? How many bracelets would I be making? Okay, well, if I got $4, then I need to also times that by 3, and I would get 12 bracelets. So this is our pattern. So now if we go over here and look at our pieces, we have bracelets sold. $1 is 3 bracelets. Well, I know that that piece is right, because for every $1, I'm selling 3 bracelets. Well, $2, 4 bracelets. Well, that's not what I got over here because I know for every $1, I'm going to have 3 bracelets. So if I have $2, I need to multiply that by 3 to get 6. So that is wrong. So I know A is already out. Okay, so if I look at B, $1, 3 bracelets. I know that's right. $2 and 6 bracelets. That was right. $4. Well, again, 4 times 3 was 12. And 5. Well, let's see. I didn't go all the way down to 5. So let's check that one. If I have $5, okay, if I'm making $5, how many bracelets would I want to do? Well, 5 times 3, I get 3 bracelets for every $1. So 5 times 3 is 15. So I know that that one's right. Well, this one is probably going to be my answer since I have check marks, but I want to make sure that I look at all of these. So $3, one bracelet. Okay, well, let's go back to our information. 3 bracelets and $1. So this should be backwards. This information is backwards. It should be a 3 over here and a 1 over here. So I know C is out. And if we go back down over here to D, we have numbers of dollars and number of bracelets. Again, it's different. It's backwards because I know that $1 would be 3 bracelets. So I know that information is also wrong. So B is my answer. Okay, so here's our next problem. There are 10 sunglasses in each display case at a store. Which table shows the number of sunglasses in different numbers of these display cases? So what are the 2 objects that have a relationship in this problem? Well, I have sunglasses and the number of cases, okay? So in all of my examples over here, I have cases on top and sunglasses on the bottom. So I'm gonna do cases. Okay, and sunglasses. Now, I picked this problem because if you know me or have seen me in the hallways, then you have definitely seen that I always have sunglasses on the top of my head. So I like this problem. So I'm gonna go ahead and do this and create some little brackets and pieces for my table. Okay, so remember we have cases on the top and sunglasses. Those are the 2 things that have a relationship in this problem. So if I have 10 sunglasses in each display case. So I have 1 case is going to have 10 sunglasses. Well, what does that tell you about the relationship that we have? Well, each one has 10. So if I have 2 cases, how many sunglasses would I need to have? There's 10 in each one. I have 10 in one, and I would add another 10 here to get 20. Okay, well, 1 and 10 have a relationship, 2 and 20. All right, if I have 3 cases, how many sunglasses would I have? Well, hopefully you were able to say 30 because I'm adding 10 sunglasses for every case, okay? But what if I wanted to jump to 5 cases and skip 4? Well, if I have 5 cases, remember there's 10 in each case. So I would count by 10. So that means I'm over here in my operations, I'm multiplying by 10. So 1 times 10 gave me 10. 2 times 10 gave me 20, 3 times 10 gave me 30, so 5 times 10 would give me 50 sunglasses, okay? So let's go ahead and look at our information over here. So what we're doing is we're trying to find the table that shows the correct information. So I know that each case has times 10 sunglasses. So that's the rule that I'm going to be using to try to find the right table. So I have cases. So 2 cases, 20 sunglasses. 2 times 10 is 20. So that one's right. 6 times 10 is not 30. 6 times 10 would be 60. So there would need to be 60 sunglasses in this for 6 cases. So I know that A is not a correct answer choice. Okay. Let's go to B. Display cases again and sunglasses. 2 cases, 20 sunglasses. Well, 2 times 10 is 20. I know that one's right. 6 times 10 is 60. 11 times 10 is 110. 12 times 10 is 120. Well, this one is probably going to be my answer since I know that each one of my cases times 10 does equal my sunglasses. But I need to go through and make sure and check. So display cases, my 2. Remember, each case has 10. So if I had 2 display cases, 10 and 10 is 20. So that one was right. 6 times 10 is 60. 11 times 10 is not 100. It's 110. So that one would be wrong. Okay, so that means C is out. Let's make sure that D is also not all correct because then I would need to go back and make sure my information was right on B. So 2 cases has 10 glasses. Okay, well, I already see a problem there because for every 1 case, there are 10 glasses in each display case. So there wouldn't be a total of 10 sunglasses for 2 cases. There would need to be 20 here. So I know that this D is already incorrect. So I know that B is the correct answer, okay? Just remember that every time that you're doing these problems, think about the 2 things that have a relationship with each other and create a pattern. Okay, so here's another problem for us. So again, this one is going horizontally. Okay, remember the tables can either go vertically or horizontally, but either way we have to find the two numbers that have relationships. So in this one we're looking up and down for the relationship. So the table shows the relationship between the number of toy airplanes made in a factory and the number of batteries needed for the airplanes. So if you have any toys at home that need batteries, that's kind of what this is talking about. There's a toy airplane and it requires batteries probably to fly around. So it might have like a remote control to fly. Okay, so think about a toy that you have that uses batteries. So based on the relationship shown in the table, this is our table, okay, which statement is true? Okay, so I'm looking for a true statement. So let's look at our information here because we already have a table that's filled out for us and we're looking for a statement that's true. So let's look at this. The number of toy airplanes is on the top. So I have 5 airplanes. Well, how many batteries would I need to operate all 5 of the airplanes? I would need a total of 15 batteries. Okay, well that helps me a little bit. The relationship is 5 and 15. Well, what if I had 7 airplanes? Then I would need 21 batteries to operate all 7 of those toy airplanes. Okay, so that's a relationship. Here I have 9 airplanes. I would need 27 batteries. Again, that's a numerical relationship. I'm trying to find a pattern with those to find out what the rule is of how I get airplanes to the number of batteries. So again, 11 and 33, 13 and 39, and 15 and 45. So all of those numbers have a relationship and I need to find out what that rule is. So let's go ahead and look through these answer options, okay? Or answer choices. The number of batteries, okay, so that's the bottom number, the number of batteries, is equal. Okay, well, I'm going to put this in a formula over here. So we have batteries is equal, okay, to the number of toy airplanes. I'm going to put TA for toy airplanes times a number. Okay, well, they all say times, so that means I know that we're going to be doing a multiplication. Okay, so batteries, this bottom number, our output, okay, is going to equal the toy airplanes times a number. Okay, so then I can look at my table and see what I'm doing. So 5 times what gives me 15? Well, I know 5 times 3 equals 15. Well, what about 7 and 21? Again, I know that I recognize that relationship. 7 times 3 is 21. 9 times 3 is 27. 11 times 3 is 33. Okay, well, those are my basic facts that I should be knowing, okay, that I should be learning in 3rd grade, or my multiplication facts with 3s. But I don't know what 13 times 3 is in the top of my head. So how could I check that? Well, by showing my work. 13 times 3, 3 times 3 is 9, and 3 times 1 is 3, 39. Well, that one is also true, okay? Again, 15 times 3. Let's just check it and make sure. 3 times 5 is 15, 5. I'm going to carry my 1 up here. 1 times 3 is 3. Add it to my 1 for my tens place, 45. That's also correct. So what would I be multiplying my toy airplanes by to get my batteries? Times 3 right here. Well, I know I'm not multiplying by 2s because 3 times 2 or 5 times 2 does not equal 15. I'm not multiplying by 6. 5 times 6 doesn't equal 15. And 5 times 5 doesn't. So that means that every toy airplane needs 3 batteries. So for one toy airplane, I need 3 batteries. So hopefully you're able to see that this would be my input is my toy airplanes and my output is how many batteries. So my answer that I proved with my work would be the number of batteries is equal to the number of toy airplanes times 3. Because the rule in my input-output table, my relationship between the two numbers is times 3.